16 grams of methane, or CH4, is the equivalent of 43.9 grams of CO2, or carbon dioxide. Don't know how I did that? Well, stick around, because by the end of this video, you'll be a pro at stoichiometry, even the tricky ones with grams, moles, and limiting reagents. Stoichiometry is the heart of chemistry. It's how we turn reactants into products, or like a recipe for a cook. And it can be a little tricky, but there's a 3-step process that I'm going to teach you to help you solve any stoichiometry problem. And I'm not just going to give you the steps, I'm going to walk you through real problems and give you some practice problems that should help you out for your next exam. And if stoichiometry is the math that we use to convert reactants into products, it all begins with having a balanced chemical equation. For example, if we take a look at the reaction between hydrogen gas, or H2, and O2, which is oxygen gas, to give us water, that's H2O. Before we begin, we need to balance our chemical equation, and I can place the coefficient of 2 in front of H2 to give us 4 hydrogens on the reactant side, and a 2 in front of H2O to give us 4 hydrogens on the product side. And the way that you read this equation is the fact that there are 2 moles of hydrogen plus 1 mole of oxygen that gives us 2 moles of H2O. So those coefficients actually correspond to a mole value. And we can take those values and figure out the mole ratio for this chemical equation. So for example, in order to make 2 moles of H2O, we know that we need 2 moles of hydrogen, or H2. And this mole ratio is going to be used as a conversion factor to do our stoichiometry problems. Let's take a look at a real problem where we're trying to see how many grams of water are produced when you combine 4 grams of hydrogen, or H2, with an excess amount of O2. First, let me show you the key conversion path for how to complete these types of problems. We know that we're starting with the mass of one of the reactants, and we first need to convert that mass into the moles of that reactant. And once we've obtained the moles of the reactant, we can use that conversion factor as our mole ratio to figure out how many moles of product. So we are going to find how many moles of the product using that molar ratio. And then once we've obtained the moles of product, then we can use the molar mass to figure out the mass of the product that we're producing. So in other words, we can go from grams to moles of product to then mass, or grams of product, once we're done. So hopefully you know how to convert between mass and moles, but if not, I have a video that you can check out to review how to use molar mass to convert to moles. Remember, the first step is that we need to convert the mass of our reactant into moles of reactant. And for that, we're going to use molar mass. So we have 4.00 grams of H2. And in 2 hydrogen atoms, there is a molar mass of 2.02 grams per mole, which means that we can use that molar mass, 2.02 grams of H2 for every 1 mole of H2, to find that there are about 1.98 moles of H2 contained in 4 grams. So then at this stage, we've completed converting grams of our reactant to moles of our reactant. And now the next step is that we need to convert from moles of reactant to moles of product. And remember, we're going to use the stoichiometric coefficients in front of each of these as our molar ratio to convert from reactants to products. And remember, there is a 2 in front of each of these, which means that there are 2 moles of H2O being produced for every 2 moles of H2. But remember, we have 1.98 moles, so that's where we'll begin. We have 1.98 moles of H2, and then we use this molar ratio, and notice that this will cancel out moles of H2 on the numerator and the denominator, and if we perform this calculation, we find that this equals 1.98 moles of H2O, which means that we are producing 1.98 moles of H2O from 4 grams of H2. So now we have completed the second step of converting moles of reactants to moles of products. And then from here, we just need to convert moles of H2O to grams of H2O. And for that, again, we can use the molar mass. The molar mass of water is 18.02 grams per mole, so 18.02 grams of H2O are contained in every 1 mole of H2O, And for that, we can perform this calculation and see that moles of H2O will cancel out because they're in the numerator and the denominator. And then if you carry out this calculation, you find that this is equal to 35.7 grams of H2O, which means that we have completed this problem and we have found that we can produce 35.7 grams of H2O if we start with 4 grams of H2. Now it's your turn. Pause the video to try this problem independently, and then resume the video to check your answers. Here's another example of how we can use this roadmap to figure out how many grams of CO2 are produced when you combust 10.0 grams of CH4, or methane. Remember, we're going to be following the roadmap where we convert grams of reactant to moles of reactant, from moles of reactant to moles of product, and then finally from moles of product to grams of product. So if we start with 10.0 grams of CH4, then in order to convert to moles of CH4, we need to use the molar mass, because remember, we are converting to moles of CH4. And for that, we need 16.05 grams of CH4 for every 1 mole of CH4. And again, if you need practice figuring out the molar mass of a substance, I have a video here that you can check out. And once you perform this calculation, grams of CH4 will cancel out because they're both in the numerator and the denominator, and this will allow us to perform this calculation where we find that there's 0.693 moles of CH4. So now that we know there's 0.693 moles of our reactant, or CH4, we can go on to the next step, which is when we convert to moles of product. And again, remember, we need the molar coefficients in front of each of these molecules to determine the molar ratio, which we can use as a conversion factor. And in this case, there are 2 invisible ones. So anytime you don't see a coefficient, that means that there is 1 of each of those molecules. So therefore, we can see that 1 mole of CH4 is turned into 1 mole of CO2. So I'll begin with 0.693 moles of CH4, which we calculated earlier. And then I will use that molar ratio where 1 mole of CO2 is produced from every 1 mole of CH4, and then I can use that to determine that there are 0.693 moles of CO2 being produced in this combustion reaction. And now we've completed the next step of converting from moles of reactant to moles of product. And now all we need to do is use the molar mass to convert from moles of product to grams of product. And the molar mass of CO2 is about 44.01 grams per mole. So then if we take our 0.693 moles of CO2 and use the molar mass as our new conversion factor, where there are 44.01 grams of CO2 for every 1 mole of CO2, then we can complete this calculation by canceling out moles and seeing that we'll only end up with grams of CO2 in our final product. And once you plug these values into your calculator, you see that you get a value of 27.4 grams of CO2. So 27.4 grams is going to be our final answer for how much CO2 is produced from 10 grams of CH4. Now, importantly, we've only been using one of the reactants in each of these examples because we've been assuming that the other reactant is in excess. That won't always be the case, and for that, you'll need to discover how to determine the limiting reagent in your balanced chemical equation. And you can check out the next video in the series for how to figure out the limiting reagent. If you check the description, I have thousands of practice problems that you can check out to help you ace your chemistry class. Drop a comment down below if you have any questions related to chemistry, and make sure that you subscribe to the channel so that you never miss out on another video. I'll see you next time.